Hey everyone, Vessel here, and I wanted to do a very quick demonstration on how to calculate outliers and just give the formulas for those since I hadn't posted that yet. And in this particular box here is the two different calculations for outliers, the two most common, I suppose. There's others that you might run into from time to time, but they're just a step-by-step breakdown here. So, I'll let you check these out. You can look at this on the on the worksheet as well. But basically, the steps are listed here, and essentially, this is really the nuts and bolts. So, using the median and IQR, you can find the lower bound cutoff point by calculating Q1 minus 1.5 IQRs, and the upper bound is Q3 plus 1.5 IQRs. And then another way to calculate outliers is using the mean and the standard deviation. Usually, you won't do both. But I want to give a demonstration in each here. So the other most common way is to use the mean and taking away and adding two deviations. So that would give you lower bounds and upper bounds as well. So, and sometimes students come into the course more familiar with 3 deviations as this outlier cutoff point. And, it's definitely something that has been a way to calculate outliers in the past. AP Statistics switched over to 2 last year. So, sometimes it's an arbitrary choice. 2, I believe, is more closely cutoff points with the IQR method. So really, it's kind of arbitrary, but this 2 is what we're going to use in this course this year. So on the other side here, there's some examples, and I've already started some of these out here. So feel free to check these out on your own here. But what I wanted to do was just give a quick calculation here, and I wanted to leave it as an exercise for you. But basically what I did for number 1 and 2 are essentially the same thing, but with number 2 I had to type in the numbers into a spreadsheet or calculator to get the mean and the standard deviation, and then I calculated the lower bound and the upper bound here. And this is for you to try. I took the 708 and I subtracted off 2 standard deviations, and I got this number, negative 743.92, and this is in millions of barrels of petroleum. And then the positive upper bound is 2159.92. So once you get the cutoff point, sometimes you go back to your data and then you look for what might be an outlier. So in this case, the UAE is an outlier, an upper outlier. Sometimes it's nice to say which side it's on there. So the data point I'm talking about here is right there. That's above 2159, so that makes it an outlier based on 2 standard deviations. And then using the pink numbers here, we have Q1 and Q3 of this data set. And again, try to get these numbers on your own, but the lower bound is calculated using Q1 minus 1.5 times the IQR. I got negative 858 for that one. So this is clearly no lower bound outliers, just like the one above. And then the upper bound cutoff point was 1874. So you look back through the data set, and there's only one number, same one. So sometimes this happens where you get the same data or same outliers in each, and sometimes you don't. But this is also an upper outlier by the 1.5 IQR method. To standard deviation method. The next example I wanted to run down was a little bit different, because in this particular case you've got everything you need, but what's different about it is you don't actually have the data points. So it's a little bit different in how you go finding the outliers. And in this case, I'll use the same color scheme. So are there outliers using the 2 standard deviation method? Well, the 2 key values here are to use the mean and the standard deviation. So the lower bound, again, is the formula. It's the mean minus 2 standard deviations. So I'll let you plug that in and see if you get this same number, but it's 1.447 for the lower bound. And then doing the same thing with the upper bound is mean plus 2 standard deviations. And again, check that for yourself, but you should get 28.435. So because I don't have all my data in this case, I really won't be able to say like specific data points. But what I do know is, based on the minimum and the maximum, that I do have at least one outlier in this data set, because the lower bound is below the minimum. So this is not an outlier. But this upper bound of 28.435, this was about inches of rain. So there was at least one year out of these 117 that was above the 28.435 because we know the maximum was 38.18. Now again, we don't know any other data points. Maybe there's some more, but based on what I know, I can just say at least one upper bound outlier because the max is above 28.435. So I do know that 1 year for sure, but maybe there's more. Don't know that positively though. Using the other method is 1.5 IQR method. Again, all you need for that are these two numbers here. So if you have Q3 and Q1, you've got enough information to check for outliers using the quartiles. And again, these are the middle 50%. So Q3 to Q1 is the middle 50. And I wanted to show you on a box plot here. So, this data set, I think 0 to 40 will work okay because of the min and max here. Here's 20. Just a little rough sketch of a box plot here. So the minimum, a little bit less than 5, about here. Q1, a little less than 10. The median is the middle here, 13. 19.2. And here's Q1 and here's Q3. And then the maximum's way out here, 38. So a rough box plot looks like this. So what I wanted to illustrate with this is the actual calculation, like what it means to calculate outliers using this 1.5 IQR method. So just as a tutorial here, the IQR is Q3 minus Q1. So in this case, it's roughly, I'm just doing this in our head here, 19.25 minus 9.68. It's around 10 or so, but the actual number is less important to me than just the visual here for a second. So but what we're talking about is like how wide is the box? That's the IQR. And then what we do with that number is we multiply by 1.5. And the reason we do that is just to make this box 50% bigger. And what we'll do with it then, after we make it bigger, we add it onto Q3 and we create some cutoff point. We subtract it off from Q1 and create this other cutoff point. So just as a number to just so see what we're working with here, 19.25 minus 9.68 is 9.57. I'm going to multiply that by 1.5 and get 14. So this number IQR is 9.57. But the key number that we're adding on and subtracting off is 14.355. That is 1.5 IQRs. So what we do with this 14.355, and you can sort of think about it just visually for a second. If I added on 14.3 to 19, I'm roughly here in the 19.2. Let's just calculate it here. So if I take my 19.2, which is Q3, 19.25, and add on, let's just do the whole calculation, 1.5 times 19.25 minus 9.68. So this number, more accurately, this is our cutoff point. So right here is the upper bound, about 33 or so, maybe a little bit higher. So this number, upper bound, is 33.605. And similarly, I could do the lower bound. The lower bound is, you can check it for yourself. It's negative again. It's over here somewhere. The lower bound, I calculated it out to be negative 4.675. Try that on your own. Make sure that you see where that number comes from. But I thought it'd be helpful to just look at what this actually is calculating here. So, the whole concept of outlier means that it's just an extreme number. And using this method of taking the box, which is the middle 50% again, of the data, because Q3 is the 75th percentile, Q1 is the 25th percentile, so this is the middle 50. You then multiply that by 1.5, creating a larger box, add it on, subtract it off, and it just gives us a sense for where numbers should kind of fall if they're not too extreme. So again, all I can conclude is the same thing I could conclude from before. I don't have all the data, but I know that at least the maximum is an outlier. So that's all I can say. I don't know if there's any other data points based on what I know. But anything above this 33.6 would be outlier. So again, sort of similar to the two means, not going to give you the same cutoff points, but in this case, it's the same conclusion, at least one upper bound outlier because the max is above 33. All right, thanks for checking it out. Hopefully this is helpful. I will talk to you later.